Hello and welcome back. You're here because you know that CI/CD is the heartbeat of modern software delivery. It's no longer enough to just name the tools. Hiring managers want to see your ability to architect, secure, and troubleshoot a production ready pipeline. Today, we are diving deep into 15 hands on scenario based interview questions, the exact kind of challenges you will face at top tier companies. I will cover everything from managing secrets to implementing zero downtime deployment strategies. If you can confidently articulate the answers in this session, you are guaranteed to stand out. Let's start preparing you for success. If this content helps you, please hit that like button and subscribe to the channel for more content. Let's start with the fundamental difference that often trips candidates up. Explain the definitive differences between continuous integration, continuous delivery, and continuous deployment. So continuous integration. So this is a development practice where you will have your developers frequently merging your code changes, often several times in a single day, into a central repository. And this action will automatically trigger a build stage and then run some basic tests like your unit tests. The goal here is to detect integration errors early. So that's basically your continuous integration. The next stage you have is a continuous delivery. Now this extends your continuous integration. After your build is done and your automated tests are successful, the code will be packaged into an artifact and automatically moved to a staging environment, making it ready to be deployed to your production at any time. The final stage here is deploying to the production, which is a manual step for us. And then you have your continuous deployment. Now this is the ultimate stage. It's continuous delivery plus full automation. So every change that passes all automated pipeline stages, your tests, your security scans, is automatically deployed to the production environment without human intervention. So basically, continuous integration is where, as a developer, we push the code, we scan the code, we trigger a build stage. Continuous delivery is where whatever the build we have done, we make it ready, we prep it to deploy to our staging environments, and then we have a manual deployment to the production. Continuous deployment is where everything is automated, including your deployment to the production. The next question we have is outline the common stages of a robust CI/CD pipeline and the primary goal of each of these stages. So the first stage you have is your source. Now this is where a pipeline will be triggered by a code commit to the version control system, like like let's say we push our code to Git, GitHub, GitLab, etc. The goal here is to fetch the latest code. Then at the build stage, now in this stage we take the source code, we compile the code, and we resolve all the necessary dependencies. The output will be a deployable artifact like a jar file or a Docker image. The goal here is to create a testable package. Then you have the test stage. Now this is where we execute our various automated test cases like your unit testing, integration testing, smoke testing, and etc. The goal here is to validate the quality and security of the package that we have created. Then you have the deploy stage. Now this is the stage where we deploy the package to your target environments. It could be a staging, dev, production, etc. This stage includes all the configuration and the infrastructure updates. The goal of your deploy stage is to release any new software version reliably. The next question we have is how do you securely manage sensitive data like API keys, database credentials, and access tokens within your CI/CD pipeline configuration? So the thumb rule is that we should never hard code our secrets within the source repository or within the pipeline. The best practice is to use a dedicated secrets manager. So we have lots of options. So we can use tools like HashiCorp Vault, AWS Secrets Manager, or Azure Key Vault to store the secrets encrypted and centrally. Then when we want to access those secrets, we can use the CI/CD runner or agent, which will be granted very minimal permissions using IAM roles or service accounts to retrieve those specific secrets only when needed during the pipeline stage, like let's say during a deployment. And then the secret is retrieved dynamically at runtime and injected as an environment variable into the running job, ensuring it never persists in logs or on the build agent's file system. The next question we have is what is a build artifact and what is the importance of an artifact repository like Artifactory or Nexus in the CI/CD process? So Build artifact is basically your final packaged deployable output that we get from the build stage, like your Docker image or a jar package or a npm package. This represents the exact code version that has passed all the initial checks. Now, why an artifact repository is important? One, immutability. So this ensures the artifact deployed to production is the exact same one that passed all the testing stages, and this guarantees your reproducibility. So whatever you have in your staging, the same will be deployed in your production. Then you have your rollback. So you can easily store previous stable versions, allowing for instant rollback in case there is a failure in your production without needing to rerun the entire pipeline. Then you have your dependency caching. So this acts as a proxy for external dependencies like your npm or maven repositories, and this improves the speed of your build and the security as well. The next question we have is, you're deploying a new version that requires a database schema change. How do you handle the database migration safely within your pipeline? So database migrations are handled by version migration tools like Flyway or Liquibase. So we can have a dedicated pipeline job which is added before the new application code is deployed. We can use SQL or programmatic migration scripts which are versioned and stored alongside the application code. Then the migration tool will compare the current schema version in the database with the available scripts and executes only the necessary forward only changes. For any critical environments, the pipeline should include a step to backup the database before running the migration, or employ a dual write-read strategy if zero downtime is mandatory, supporting both old and new schema versions concurrently during the deployment window. The next question we have is, describe the blue-green deployment strategy and explain how it achieves zero downtime. So blue-green deployment basically uses two identical production environments. Like blue will be your environment which runs your current version, let's say v1, and green will be your new version where you'll be deploying your v2. So the process is, your version 2 is deployed and tested thoroughly on the green environment, while all the traffic still goes to the blue environment where you have your version 1. Once your v2 is validated, the load balancer is instantly switched to route all the traffic to your green environment. The old environment is kept as a standby for quick rollback in case your v2 fails, or decommissioned once v2 is proven stable. So with this, users will experience zero downtime because all the traffic is switched instantaneously at the load balancer level, and the new environment is fully live and tested before the switch occurs. The next question we have is, your deployment to production just failed a crucial post-deployment health check. What is your immediate and preferred rollback strategy? So the immediate action is to automate the rollback to the last known stable version. Trigger an automated rollback job which points to the load balancer or traffic router back to the environment which was running the stable version, like your n-1 version. Why you want to automate this? Because manual rollbacks are very slow and error prone. The pipeline must have an inherent swift rollback capability tied to failure notifications, like monitoring alerts as well. So if you are using blue-green deployment, the rollback is very simple. You're just going to switch the traffic back to the blue environment. For rolling updates, the system can automatically redeploy the previous stable artifact version. The next question we have is, when implementing CI/CD, which Git branching strategy, trunk-based deployment or Git flow, do you prefer and why? So in my case, I would prefer the trunk-based development for its emphasis on continuous integration, rapid deployment. So in your trunk-based development, developers commit small frequent changes directly to a single branch, could be your main branch or your master branch, using feature flags to hide any unfinished work. This enables extremely fast CI/CD cycles with very minimal merge configs and ensures the trunk is always deployable. But if you want to use Git flow, then you will be using long-lived branches like your develop branch, feature branch, release branch, etc. This can lead to merge hell and is fundamentally at odds with the continuous deployment due to the complexity and time required for merging. So for a high velocity CI/CD environment, trunk-based development is the superior model. The next question we have is your CI build time has increased from 5 minutes to 15 minutes. How do you find the bottleneck and what optimizations would you suggest? So the first thing is we will need to analyze the pipeline logs and the CI server's internal timing reports to identify which stage or which job is consuming the most time. For example, fetching the dependencies or running the test cases or during the compilation. So basically, which stage is consuming more time. Now, if you want to optimize this, then you can consider using caching dependencies. So implement aggressive caching for dependencies so they aren't re-downloading the packages during every build. Then parallelization. So run independent jobs like different test suites or linting in parallel across multiple runners or agents. And then incremental builds. So use compiler features or tools that only build the parts of the code that have changed, reducing the compilation time. Finally, scaling the runner. So ensure the CI runners have adequate CPU or RAM resources and can auto scale to meet the demand. The next question we have is how does infrastructure as code using a tool like Terraform or CloudFormation integrate into your CI/CD pipeline? So infrastructure as code is fundamental and runs as a distinct stage before you deploy your application. So basically, you will have a dedicated provision or infrastructure stage which is introduced early in the CI/CD pipeline. The stage executes your IAC tool like your Terraform plan and then Terraform apply to create or update the target environment like creating VPCs or creating databases or load balancers. This ensures the application always deploys onto an identical, version controlled and reproducible infrastructure. And if the infrastructure changes, it goes through the same review and testing process as the application code. The next question we have is how can you deploy an unfinished feature to production via continuous deployment without exposing it to all the users? So for this, we can use something known as feature flags or feature toggles. You can wrap the new feature code in a conditional statement that checks the status of a flag. So whether the flag is enabled or not. The flag can be managed by a dedicated service like launch darkly or a configuration service like console. This allows the feature to be toggled on or off dynamically without redeploying the application. This decouples the deployment of your application from release. The code is deployed automatically, but the feature is released gradually to internal testers or a small percentage of users by changing the flag setting. The next question we have is you have a microservices architecture. How would you structure your CI/CD pipelines? So we can implement a pipeline per service model. So basically each microservice lives in its own repository and has its own independent CI/CD pipeline. Code commit to service A's repository only triggers service A's pipeline, and this minimizes the build or test time and deployment risks. You can also use an orchestrator tool like Kubernetes or a high-level pipeline tool like Jenkins, GitLab, Code Pipeline for any necessary end-to-end testing or cross-service dependencies. This ensures services can be developed, tested, and deployed autonomously at their own pace, which is the core principle of microservices. The next question we have is contrast blue-green deployment with Canary deployment and explain when would you choose Canary. So, like I said, blue-green deployment is having two identical environments. So we can choose Canary deployment when I need to perform A/B testing or when the risk of an unknown production-only bug is high. So by slowly rolling out the new version to a tiny subset of real users, I can monitor key metrics like your latency, error rate, and also limit the blast radius of a failure before it affects the entire user base. So basically you have a new feature, but you're not sure how this would affect, whether it will work or not. That's when you can go with a Canary deployment where you're releasing that feature only to a small portion of your users. The next question we have is what is flaky test and what is its negative impact on the CI/CD pipeline? How do you deal with them? So a flaky test is a test that can sometimes pass and sometimes fail on the same code commit without any changes to the code itself. So flaky test destroys developer trust in the pipeline. Developers start ignoring failures, leading to actual bugs slipping into production and rendering the CI process meaningless. And this also wastes build agent time. The resolution for this is to quarantine. Immediately isolate the flaky test so it does not block the main pipeline. Then debug. So analyze the root cause, Flakiness often results from improper test cleanup or resilience on external services or race conditions. And then finally, fix or rewrite. So the test must be fixed to be deterministic and reliable before being reintegrated in the main pipeline. The next question we have is explain the concept of shift left in the context of CI/CD security. So shift left is simply the practice of moving security and your quality assurance activities earlier into your software development lifecycle, like shift left on the timeline itself. So traditionally, security audits happen late, very close to the deployment. You can integrate your shift left. So basically, you can implement your shift left by integrating security tools directly into your CI stage. You can use tools like SAS, which is your static analysis security testing. So we can use this to scan the source code for vulnerabilities during the build. Then you can use dependency scanning. So check all the projects libraries for known CVEs, and then container scanning. So scan Docker images for known vulnerabilities before they are pushed to the registry. The benefits of this is that this will catch vulnerabilities when they are cheap and easy to fix while the code is still in the developer's desk rather than hours before a production release. And that brings us to the end of this session. So we have covered 15 powerful real world CI/CD scenarios questions. You now know how to manage secrets with a vault, implement zero downtime, blue green, troubleshoot pipeline bottlenecks, and handle complex database migrations with confidence. Mastering these concepts is the key to landing that high paying DevOps cloud engineer role. If you found this session helpful, smash that like button, subscribe to the channel for more content, and let me in the comments section if you have any queries. Thank you for watching, and I will see you in the next session.